Mechanical Drawing, Sketch Your Ideal Blueprint. Hello, everyone. Welcome to the micro class on Mechanical Drawing Recognition and Tolerance Fit. In this lecture, we will learn the standard drawing methods for threads. In various machinery and equipment, we often see parts like bolts, nuts, and screws. They serve the purpose of connection. These parts share a common feature: they all have threads. Even in daily life, threads are everywhere. Since threads are standard parts, their drawing methods and markings have special regulations. Next, let's first get familiar with the drawing. The first step is to read the title bar. From the title bar, we can see that the part name is a threaded shaft, made of 45 steel with a scale of 1 to 2. The second step is to read the views. The main view uses a broken-out section. The locally enlarged view is drawn at a scale of 2 to 1 to show the thread profile structure. There are center holes at both ends of the shaft. The third step is to read the dimension markings. The radial dimensions of the shaft are based on the center line. The length dimensions are mainly based on the left end face of the 48 mm diameter shaft section. There are two threads in the drawing. One is a trapezoidal thread with a nominal diameter of 36 mm. The other is a metric thread with a nominal diameter of 24 mm. Pay attention to the thread marking method, which is consistent with linear dimension markings. The undercut groove dimensions are 6 × 5, 28. The fourth step is to read the technical requirements. First, let's look at the surface roughness. The surface roughness values, marked in the drawing for the trapezoidal thread and the 48 cylindrical surface, are 1.6 micrometers. The surface roughness for the M24 thread is 3.2 micrometers. The rest are 6.4 micrometers. Next is the textual description section. Unmarked tolerance dimensions in the drawing follow GB T1804-M. In this lesson, we will focus on learning the standard drawing methods for threads. Threads are generally not drawn according to their true projections. Instead, we use the drawing methods specified in the National Standards for Mechanical Drawing to simplify the drawing process. Let's look at the first knowledge point. The drawing method for external threads is shown in the figure. The representation of external threads generally consists of two parts: a view with a non-circular projection and a view with a circular projection. In the view with a non-circular projection, the crest line of the external thread, which is the major diameter, is represented by a thick solid line. The root line, which is the minor diameter, is represented by a thin solid line. The minor diameter is taken as 0.85 times the major diameter. Meanwhile, the thin solid line of the root should extend into the chamfer. The thread termination line is represented by a thick solid line. The tail end of the thread generally does not need to be drawn. The specific drawing steps are as follows. During the drawing process, pay attention to the use of thick and thin solid lines. Throughout the entire drawing process, thin solid lines are only used when drawing the minor diameter of the thread tail, and the break lines for sections. The rest are all drawn with thick solid lines. Let's take a look at the drawing method for internal threads. When drawing internal threads, a sectional view is generally used for representation. As shown in the figure, in views that do not show the circular shape, the major diameter is represented by a thin solid line. The minor diameter and the thread termination line are represented by thick solid lines. Moreover, the minor diameter is taken as 0.85 times the major diameter. It should be noted that the section lines should extend to the thick, solid lines. In views that show the circular shape, The major diameter is drawn with a thin solid line arc of about 3/4 of a circle. The chamfer circle at the hole opening is not drawn. The specific drawing method is as follows. The above two drawing methods only show the drawing of a single thread. However, threads are generally used in conjunction with both internal and external threads. Next, let's look at the drawing method for the engagement of internal and external threads. First, we need to clarify one point. Only when the 5 basic elements of the internal and external threads are the same can the internal and external threads be connected. Second, the representation of thread connections generally uses sectional views. During the drawing process, the engaged part of the internal and external threads in the thread connection is drawn according to the drawing method for external threads. The unengaged parts are drawn according to their respective original drawing methods. The specific drawing method is as follows. When drawing, the following must be noted. First, the thin solid lines and thick solid lines representing the major diameters of the internal and external threads, as well as the thick solid lines and thin solid lines representing the minor diameters of the internal and external threads, should be aligned respectively. Second, in sectional views where the cutting plane passes through the thread axis, the solid screw rod is drawn as not sectioned. Third, whether it is an internal or external thread, the section lines must extend to the thick solid lines. Through the above study, we have roughly understood the standard drawing methods for threads. So, classmates, using the knowledge you've learned, can you now independently draw a thread connection? Alright, that's all for this lesson. Welcome to continue following our micro class mechanical drawing recognition and tolerance fit. See you next time.